Okay, guys, let's talk some more circle equations. Here again, we're writing equations of circles. So of course, we're going to need that center and the radius. Or we might just be given a point, but we still have to find the radius in one way, shape, or another. So let's just jump into it. So we know we need to get our circle equation first. Let's establish that we're writing, here we go, x minus h quantity squared, y minus k quantity squared is equal to r squared. Let's figure out what we have to work with. So here I have a center, 5, 2, so that's going to be my h and k. And then I actually just told directly my radius is 7, and so this becomes a direct substitution problem. So of course we're going to keep the infrastructure. Okay, so those are all parts of the equation that are not getting substituted. Here we have a 5 and a 2 going in for h and k. No double negatives here because they're both positive, and of course we have the 7 going in for the radius. And so let's clean this up, and so this is just a copy because there are no double negatives. Y minus 2, and we'll make that equal to 49. Okay? So continue the work. Again, we're going to have x minus h, y minus k is equal to r squared. The center, again, we're given directly, h and k. And look at that, they're even being nice and giving us a radius value of 2. All right, so let's set up our equation. All right, so we have 3 in for h, we have a negative 2 in for k, but it looks like we do have a double negative here. Radius value is, of course, going to, hey, change color. It's going to be 2. All right, so cleanup step, we have x minus 3 squared, we'll have y plus 2 squared, and that's going to equal 4. All right, let's see if this is going to scroll today. No? Yes? All right, so given a circle with center 3, 4, so we know we have h comma k. It passes through a point, a random point, x comma y of 6, 2. And so we already kind of established what the thought process here is. So we know we're going to use the equation to build the radius value, or actually the radius squared value. Okay, so we're going to solve for that r, or that r squared, so we can write our equation. And so we know we have to do a full substitution, not just the x and y, but also the h and the k. Okay, so the x and y values come directly from our point, 6 comma 2. H and k, 3 and then negative 4, with double negative. Okay, so 6 minus 3 is of course 3. 2 subtract negative 4, that's going to give me a 6. And so we have 9 plus 36 is equal to r squared, which I'll just flip it on the other side, is going to give me an r squared value of 45. That's what I tried to write anyway. All right, so going back to our equation. Okay, we're going to keep the x and y because we're reverting back to a general equation. And the r squared value we just found to be 45, so we can keep it as a 45. We do have to substitute our center back in, so we have 3 and we have negative 4. And then in a cleanup step, because we do have a double negative here, we'll have y plus 4 squared, and that's still equal to 45. Okay, and so hopefully you're seeing some repetition here, building from the equation to get our result. All right, so here we have another one where we don't have, or we do have the center, excuse me. It's going to be at the origin, and so that implies h and k is going to be at 0, comma 0. And then the point it passes through is going to be 4, comma 3. Okay, so we're going to start with the equation. And we're going to use that equation to find our r value. Okay, we have x and y, so 4 and 3. We have h and k, but they're both 0. Okay, and so we have 4 squared plus 3 squared is equal to r squared. So 16 plus 9 is equal to r squared, or our r squared value is just 25. And again, I know that means our radius is going to be 5, but that's not necessary to write the equation. We just have to substitute in our current center. Okay, and so r squared is known to be 25. Our center is 4, 3. No substitution, no cleanup here to do because we don't have double negatives. And so that's going to be our circle's equation, okay? And so much like the previous videos, hopefully you're seeing a rhythm here. We always have to start with the equation. We're gonna substitute the parts we know so we can solve for the part we don't. As I mentioned before, yes, it's totally valid to use like a distance formula or Pythagorean theorem to find the radius value and then substitute it. I just think this method tends to be more efficient, okay? One more page of this and then we move on. So I'll see you then.